Dear student, in this video, I am going to share the next part of conformations of polysubstituted cyclohexane. In previous video, we discussed about these three molecules. Now here, we are going to talk about the fourth molecule, that is 1-phenyl 2-amino cyclohexanol, and the remaining these points that we have to cover in the successive videos. So the first here 1-phenyl 2-amino cyclohexanol. This is the structure of 1-phenyl. At first position, the hydroxy and phenyl group is present, and the second position, amino group is present. As the two asymmetric centers are there, it exists in two DL pairs. Let us first of all talk with the cis one. In this case, this compound is termed as a cis compound. The orientation of hydroxy group and NH2 group, the orientation of this two group is in the same direction. Therefore, this molecule is termed as cis molecule. The flipping structure of this one is is shown over here. So the first one is unstable. The reason behind it, this is the congested structure. While the second one is the stable, the reason behind is there is no congestion. So this structure is more stable as compared to the first one. Therefore, equilibrium arrow shown in the direction of this conformer. Therefore, for cis molecule, this structure is stable because of no congestion. So this hydroxy group and NH2 group, as they are facing in the same direction, therefore there is presence of intramolecular hydrogen bonding. So in cis molecule, if both the polar groups OH and NH2 are facing in the same direction, due to that there is a presence of intramolecular hydrogen bonding. Now this is the mirror image of cis compound, that is the more stable conformer of this. These are the mirror images of each other, and again it exists in a DL pair, indicating absence of symmetry. Therefore, it is optically active molecule. This is the mirror image which are shown in the ball and stick model. So this is the same this one structure, and this is the mirror image of the first one. Now the trans molecule. So in the trans molecule, the orientation of hydroxy group and NH2 group, they are in the opposite direction. So this isomer is termed as a trans isomer, and this is the flip structure. Now, how to name this? This is axial, equatorial, and this is axial one. While here, the two bonds are equatorial and one is axial. Therefore, the first structure is more stable because phenyl group is at equatorial position, while the second structure is unstable. The reason behind it, the phenyl group is at axial position. Therefore, the first structure is more stable as compared to the second structure. So the equilibrium arrow shown towards the first structure. As hydroxy group and NH2 group, they are in the opposite direction. Therefore, there is absence of intramolecular hydrogen bonding. Now, this is the trans molecule, which is more stable conformer. The mirror image of this is shown over here. Again, it exists in the DL pair, that is absence of symmetry element, and hence it is optically active. So the same thing that is shown over here, that is the three-dimensional structure, this structure where the phenyl group is equatorial and hydroxy and NH2 group, these two groups are axial. And this is the mirror image of this structure. So for this, you go through the same references that I have mentioned over here.